So do you remember bigger on top, bigger on bottom, same on both? Do you remember that part about finding horizontal asymptotes? They're always y things. So here's an example of one. Is this one, let's go with 13 on the bottom. Clearly it's bigger on the bottom, right? No. This one's actually what? Same on both. If it's the same on both, the degree is what we're talking about here. If it's the same on both, then your horizontal asymptote is that y equals, they're always y equals things. What would it be if it's the same on both? Remember the same on both, guys? It's the ratio of the lead coefficients, 1 over 13. There would be an asymptote at y equals 1/13. Do you get that? Okay, then let's talk about bigger on top. Say it was like that. Is it bigger on top, truly? Then what would its asymptote be? Then here's what I would want you to write if this was the one I put up. I'd want you to write, oh, that's bigger on top, and the answer is there is no asymptote. On your iPad, you'd write that, turn it, and show it to me. Okay? That's what we're going to do for the next 3 or 4 minutes, is I'm going to make sure you get, if it is bigger on top, what is the asymptote? If it is bigger on bottom, what is the asymptote? By the way, what is the rule for bobs again? It's what's on the outside, yes. So this one is bigger on bottom, true or false? True, and therefore the answer is, since it's a bob, you go, it's y equals whatever's on the outside, y equals 7. That's what you'd write on your iPad. You get what I'm doing here. All right, so be prepared to write right now. Get a clean screen. You ready? Thick pen. This is a tough one, and take you a second to figure out, is it bigger on bottom, bigger on top, same both? Write it down, and then write y equals whatever the answer is. What is the asymptote then? If it is, let's say it's bigger on top, then what is the asymptote? All right, nice job, you got it. You got it. You need 3 letters. You've got it. You've got it, you've got it. Good, 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 good. Yes. Not. Yes, 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 it needs a letter y equals. Yes, it needs a y equals. Good, good, good. Okay. This was same on both. Why? Because when you multiply that out, it would be x squared. And therefore, it's the same degree. And if it's the same on both, you take a ratio of the lead coefficients, which is 6 over 1, which would be 6. So it was an SOB, and it was 6. That's what I was looking for. Okay, y equals 6. Next kind. This is a little trickier. (3x squared over 1 minus 5x squared). So, what is it? Bigger on top, bigger on bottom, same on both. And then, what's the asymptote at? No. Your letters are right. You've got it. Good job. You don't have a right letter. You don't have one of your numbers right. You've got it. I can't, they're so thick it's hard to tell what those numbers are. I think you've got it. Yes. 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 I'll get back to you. Yes. 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 That's good. All right. You have to have y equals to be right. Good. 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 All right. Hold on. Okay. Was this one bigger on top, bigger on bottom, same on both? What was it? Same on both. I agree. And if it is the same on both, it's a ratio of these lead coefficients, which are this and this. Excuse me, I'm talking right now. And these two, good. These two are the lead coefficients. Just let me explain it then. And that's a lead coefficient over that's a lead coefficient. And there you go. Okay? Any questions on that one? That's about as tough as they will get. So this isn't too hard. Now, on the homework for tonight, it is just basically more of the same kind of stuff, except it's got a little more graphing on it. So you actually have to make graphs for these things. So let's look at number 5, for instance. Would you agree that that is the same on both? Okay, if it is the same on both, then it should have a ratio of the lead coefficients and stuff, right? And what would that be in this case? 3 over what? Which is y equals 3. So y equals 3 seems like it's kind of important. But in this case, this is kind of an important point. This one, do you get if I factor the top, I'm going to all of a sudden have something cancel on the top and the bottom? What does that make? Y equals 3. That's just a line at y equals 3, not an asymptote. Why? Well, what are the lead coefficients? There aren't any coefficients anymore. They canceled. There's no variables, and therefore there's no coefficients. So therefore, if everything cancels and you're down to just a number, like y equals 3, that is not an asymptote. That's just a line. Okay? So our rule is ratio of the lead coefficients. What if there aren't any lead coefficients? Then you can't use that rule. There aren't any asymptotes. Okay? So if all the variables cancel and you're down to just a number, then it's just a straight line at that number and it won't be an asymptote. Okay, so back to this one. It's right, except now what's this supposed to make? A hole where? At 2 or negative 2? At negative 2. So there should be a hole at negative 2. So I'm going to make just a little empty spot there. And I'm going to go like this. There's my hole at negative 2. That's how your graph would look for that one. Let's pop over to number 4. We're actually doing your homework. If you want to find it on Schoology, and it's worksheet C as in cat, or as in cataclysm, or cataclysmic event. Apocalypse with us. Okay, good. Anyway, this one cancel this one. And all of a sudden I have y equals x plus 3. Is that bigger on bottom, bigger on top, or same on both? That is bigger on top because the bottom would be a 1. You get that? That's bigger on top, and therefore bigger on tops don't have any asymptotes. There's no bots, so there's no asymptotes that way. Is there any hole on this graph? Yeah, the thing I canceled out would make a hole. So I just graph y equals x plus 3, which I hope you haven't forgot basic algebra. This is just a slope of 1 and the y-intercept of 3. So I'm going to touch here, and I'm going to slope of 1. It's going to go like this. And then there needs to be a hole on that line. Where? At 4. Positive 4? Yeah. So at positive 4, it's off the graph a little bit. I'm just going to extend my line out a little farther so I can see where that would be. And keep this going until I hit where 4 would be. And then I have an empty spot right there, and then I keep going. If you look at the key, that's exactly what the key looks like. You got to go off the graph a little bit to get to where the 4 is. See? The 4 is where the hole would be, right up there. Yes? When the semester's over and you've got your grades and you like, yep, that's right, then you can delete all your old homework cases. I get you that it's adding up to be a lot of assignments in there. So once everything canceled, that's the first thing to do is cancel everything. Once everything cancels out of there, you look at what you have left and you just graph that. And that's just an old school, y equals x plus 3. You've graphed that since like like 5th grade. You were able to graph that. Okay, and it's just this. Nowadays, in 5th grade, you might have done it with like points. Like if you put in a 1, you get a 4. 1 comma 4 is on your graph. And you put a dot there, and you make a bunch of dots and you connect it. But now you're old enough to go, oh, this is the y-intercept, and that's the slope. So y-intercept's 3, slope is rising 1. And, all right, need an empty spot right there. Okay, I've done a couple of your problems for you. If you're stuck on verticals, horizontals, etc., we are going to be doing more review tomorrow, and then you have a quiz on Thursday. All right, so make sure tonight, do some serious, get your homework done, check it, make sure you know what's going on, because tomorrow's your last chance to ask me questions. If you're stuck, tomorrow is it. All right? And then you get the test on Thursday. So we'll do another review tomorrow, but be good about doing your homework tonight. Okay, so thought I was going to end there, but I'm going to add just a little bit to it. I want to find one of the more normal questions. Shh, quiet, please. Don't talk right now. Thank you. I'm going to show you one more question on your homework. I can look at number 2 for a minute, but it's not that hard, for Pete's sakes. It's just a graph that goes like this. This is one of those, this is the parent for it, you know? Except it's been moved where? Left 3. The whole thing gets moved to the left 3. So if I were you, I'd start with the asymptotes and say, okay, what kind of asymptotes should this thing have? This is bigger on the bottom, so it's y equals the outside. The outside has nothing on it, so it's y equals 0 as an asymptote. Dot, 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 dot. There's y equals 0. Then the x one. The x asymptote is whatever makes this denominator equal 0, which would be negative 3. Okay, can you stay focused, please? Second time I've had to talk to you in 5 seconds. First noises and then that. Okay, stay focused. Here's the negative 3 part. Okay, so there's my asymptotes, and now I can just draw my graph in there. And it would go like this. These are the 2 key spots. And it looks something like that. There's no holes on this one or anything, so it's the butterfly kind of graph, except shifted to the left 3 spots. You get that? All right. Now I want to show you the other kind that's actually, there's a lot of this that you're going to have to know. Everybody go to number 10. Find number 10 on your worksheet. Let me help you with number 10. Okay. Top part, can I factor x plus 1 any more than it already is? No. So it's x plus 1. On the bottom part, can I factor that? I certainly can. Do you know how I could factor it? X plus 2 and x plus 1. Okay. So first step, factor it. This is number 10 we're doing right now. Next step, see if anything cancels. Is anything going to cancel? When you cancel it, don't just make it disappear. It technically gets replaced by what? A 1. So now I have just found a hole. And like I told you, I start from the bottom up on these graphs. So I'm going to go down and do the hole part first. Where's the hole going to be? At negative 1 comma something. And then how do I figure out where the rest of the hole is? Well, I could graph it and like look and see where the hole ends up. Or I can stick a negative 1 into the equation I have left. This is a step that I didn't do, that a lot of you don't do. Write out what equation is left after that hole cancels. It's just 1 over x plus 2. After this is gone, do you get how what's left is 1 over x plus 2? That's the equation now that we have. What is that? That's just a butterfly that's been shifted where? Left 2. Okay, so I'm just going to go and make my asymptotes like this, and it's one of these kind of graphs. There, except it's got a hole where? At negative 1. And negative 1 is right in that zone. Need a hole at negative 1 right there. There we go. So now I go back and fill in this stuff. Where's my horizontal asymptote? Horizontals are the ones that Bob will tell you. What's this one? Bigger on bottom, bigger on top, same on both. Bigger on bottom, and so therefore it's y equals whatever's on the outside. Is there anything on the outside? So it's y equals 0. The vertical asymptotes, those, yes, question. Bob is the outside. Bot, if it's a bot, there's none. Bot is not. And then the last one is same on both, and those are the ratio. Okay? All right, back to what we're doing here. My equation is just this. It's just one of those butterfly ones, except shifted 2 to the left. And then it's got a hole based on this thing right here. It had a hole at negative 1. That's why I put that I've just got right there. So what's the vertical asymptote? Vertical means up and down. That means this line right here. And that is at x equals negative 2. where could I have also found it? Right there. It's the thing that crashes the denominator. And the last thing is the domain. Always start with all real numbers, and then you say x cannot be whatever. And what can't x be? It's these guys. It can't, no, sorry, not that, I circled the wrong thing there. I should have circled this, and this are the two things that x can't be. So x cannot be -2, and x cannot be the whole, which was at -1. All right, we'll practice this more tomorrow. Yes? Question about that one? Let me see. They aren't on the same line. One's x plus 4, one's x minus 4. His question was, what if the asymptote and the whole are on the same line and they're not? Do you get that that one's the whole? And that the whole's at +4. The asymptote would be at x is negative.